Okay, so your page 6 should look just like my page 6 or what I have up here on the board. So first thing I'd like you to do is on page 6, if you would turn your paper so it looks like mine, I believe that means the holes have to go on the bottom. So you're turning your paper sideways with the holes on the bottom, I think, right? All right. We want the arrows to look the same way. Yeah, you gotta flip it over, don't you? No, not yours. That's why is your paper different than mine? That makes me nervous. Oh no, you do need to. See how yours. Oh,
no, hers is right.
But why is it different?
Wait, no, because no, the hole's got to be on the bottom.
They do. Yes. See,
it looks the same, but they're different. It's very close. But
how are they different? They're not. Oh, you need the north at the top. There you go. Yeah. Yeah. So if you do it like this, the north's on the bottom. All right, let's try this one more time. So everybody take that paper and we want your packet. So if you have holes, they're on the bottom. If you don't have holes, then we're gonna look at the directions there at the top. They're gonna be on the right side of your paper. So everybody's got their paper sideways so it looks exactly like the one on the board. That was harder than I thought, even for myself. So there we go. Everybody good? Nope, still waiting for a couple people to grab their packets out. All right, so first thing, we spent the whole period basically last time just kind of looking at the model, talking about the difference between summer and winter, fall and spring by looking at the model. The model makes it a little bit easier to see all of this stuff because you can actually see where the earth is, and it does make it easier to have it here in front of you. Unfortunately, for the regents and for a test question, you can't have this cool model sitting in front of you. You have to work with a piece of paper. So the first thing I want to point out is on this sheet of paper, it almost more looks like the earth is going around the sun more this way. And I want to make sure you realize that the earth is still going around the sun, kind of coming out of the paper and going back in. So this is how they show that. What I'm getting at are these two on the top and bottom. There is no time when the earth is on top of the sun or underneath the sun. They are all in line with the sun, more in a three-dimensional shape. A couple other things. So what we have going on here on this page 6, this is the sun in the center. You knew that, right?
Yeah.
Okay, this is the sun. This is the earth. How many earths are there really?
One.
There's really only one. Why are they showing 4 here?
Because it's showing where they go.
Okay, it's showing it in 4 different days of the year. In fact, these 4 positions represent the first day of spring, summer, winter, and fall. So there really is only one earth, and these are representing the earth on the first day of each day of the first day of each season. Your first job will be to be able to identify which one's spring, which one's winter, which one's fall, which one's summer. So based on what we were looking at on that model on Friday, can you guys look at this picture and first think in your head, don't say anything out loud, which one of these is summer? Let everybody think. We did everything. We talked about this on Friday. You should be able to identify which one's summer. You know? You think? What was some of this stuff? Here, I'll put Earth on my model in the summer position. Right here is summer. What do we know about Earth on the first day of summer? Oh, it is hot, but what do we know about the location of Earth? This, remember, we talked about this was summer. You guys kind of laughed at me when I talked about it bowing to the sun. But see how this earth is kind of leaning like it's bowing to the sun. I say it's worshiping the sun. It's a sun worshiper. We, just like us around here, we have been outside these past week or so because we're like, sunshine!
Yeah.
Yay! So this earth is doing the same thing. It's so excited to see the sun. It's bowing down to the sun. So that is how, and yes, that is why it's hotter in the summer. That is why we have longer days. We went through all of that on Friday. But by looking at this model, we know which one is summer based on which one's bowing to the sun. So which one is bowing to the sun on this paper? The one on the left. This guy is summer right here. And why don't we go ahead and label that globe summer? So the globe all the way to the left is going to be labeled summer.
Oh, I knew that.
So the other side is spring.
Wait, what is opposite of summer?
Winter.
Winter. Oh, that's what you meant. That's exactly how I answer that, by the way. You know how just like with high pressure, I only knew high, dry, cool, and clear, and I knew nothing about low pressure?
Yeah.
I also know nothing about winter here. I just know it's opposite summer. So same idea, you find summer first, then you know that directly opposite of summer is winter.
I thought it was just
No, I know where spring and fall is.
So then, for spring and fall, those two globes look exactly the same, don't they?
Yeah.
So how do we know which one's spring and which one's
Spring's on top.
why is spring on top?
Because spring is before summer. Fall's after.
Well, how did you know this one was before
Because the
summer?
arrows
Gotta
follow
follow
you.
Exactly. You will have to follow the arrows to decide which one's spring and which one's fall. Because on paper, they look exactly the same. So remember, the regions will try and mess with you. One thing they can mess with you about is changing where the arrows are. So they might switch which way this is going. So don't just memorize summer's on the left, fall's on the bottom, winter's on the right, spring's on top. You can't memorize that. You have to, every time you see one of these diagrams, work through it the exact same way we just did. First, identify summer by figuring out which one's leaning towards the sun, which one's bowing to the sun. Then you find winter directly across from it. Yes, in this case, it is leaning away from the sun as well, but as long as you just remember it's opposite summer, you're good. Then follow the arrows around. Summer, then fall, then winter, then spring, and back to summer. So always, that is the system I want you to use when identifying each season in a picture. So that part's something you just got to be able to do. Really, the only thing you have to memorize is that in summer, the sun is, or the earth is leaning or bowing to the sun. Really the first thing and only thing you have to memorize about that. But then you have to know some fun facts about each season. First things first, you need to know their official name. So we just keep calling it the first day of summer, the first day of winter, spring, and fall. You do need to know the official name. And so some of you already know, Sarah just said it. Solstice is one of them. And equinox is the other set of names. So the solstice is for summer and winter, and then equinox are for spring and fall. So what we're going to do is I have notes set up. You got the exact same picture I do. So let's do the summer solstice first. Again, which one's summer solstice? The summer one.
Yeah, but
so summer, these are the first day of each one of these seasons. So that leads me to one more thing. I was kind of off of what I wanted to. Where is summertime? Like, where is that on this? Like the whole summer, not just the first day.
Okay. Probably like everything.
Everything?
Until fall.
Everything until fall. So that's a very good point, and that's a good way of putting it. It's everything from the first day of summer until the first day of winter. So we could label this set of arrows here summer time. And maybe we should have added first day up here where we labeled it just summer. That's probably a better choice. So can you add first day to summer and then summertime here? So by summertime, I mean like the whole time we're off pretty much. Like June, July, the end of June, July, August.
Well, technically we're not off for the entire summer.
You know, we're not. You're right.
That was just dumb.
I wish you were off longer, but. I think we could just be off
Okay.
every year.
So again, if you want to add first day to all of these, that'd probably be a good idea.
Well, are you policing my real?
Hey Sam, or Zach, if you're going to be rude, you can leave. All right. Then, like I was saying, we do need to basically memorize some facts about each first day. The first thing you have to memorize is their official name. So this first one, and so notice I put the notes down in the lower left corner. If you guys can't see something, let me know, because I know it is kind of hard to see.
I can see. Okay.
So I did put an arrow pointing to this one, so make sure you know which globe you're talking about. So Jeff, yeah, add an arrow to yours pointing to this globe.
Yeah.
Okay. Summer solstice, you have to memorize the date. It is June 21st. We're going to talk about the Tropic of Cancer. This Tropic of Cancer is where the sun is hitting directly. We're going to talk about that on the next page a little bit more. It is the longest day of the year for us here in Northern Hemisphere.
That's cool.
No. By the way, what do I mean by the longest day? Do I mean it's like 27 hours or, right. It's still 24 hours for that day, but it's the most daylight. So if you didn't catch that, if you want to say longest daylight, that might be better for you guys. Yeah. And that's for us here in the Northern Hemisphere. What do we know about in the Southern Hemisphere during our summer? It's the opposite for them. Our summer is their winter. So right now, we're almost getting to summer. In the Southern Hemisphere, they're just now getting to winter. So in Australia, in South America, it's almost their winter. So if you wanted to have an extra winter, all you got to do is go take a vacation in July to Australia, and it's an extra winter.
So
yes.
Here,
so truth again, if you want during our winter, so December, January, February, it's their summer. Well,
I think our winter starts.
I think it's just opposite. So they still use the, so instead of having winter in December, January, February, they have winter in June, July, August.
So that's Europe.
Wait, what's the first day of spring? March 1st?
Yeah, so us in North America, Europe, Asia, Japan, China, they're all like us. But then for the Southern Hemisphere, so South America, parts of Africa, Australia, Antarctica, it's all opposite.
South America is real.
Okay, we've already established that, but it is.
I believe
Now, by longest day, the number of daylight hours will switch depending on how far north you are. We learned that last chapter. Because remember, it starts at 12 hours at the equator and then gets up to 24 hours of daylight at the North Pole. For us, we get about 15 hours of daylight on the first day of summer.
Oh.
15?
Not enough.
Oh my gosh, you're
I
demanding.
need the whole year.
Watch your language.
So I'm switching over to the winter solstice. I'm not quite sure why I didn't go in order here. I guess I was getting the solstices out of the way. So the winter solstice, December 21st. Yeah, guys, you gotta memorize the date. Again, make sure you draw an arrow to show which globe we're talking about. We're talking about the one on the far right.
21st part, I probably will.
Oh, yeah, Cancer, Capricorn.
What the?
Yeah, I
Please don't.
I don't follow it either.
Please don't talk
I'm
about
an Aries.
whatever. Go, Miss Red.
Me too, Miss Red.
Daylight do we get?
Good question. Thanks for staying on topic. In Buffalo, we get about 9 hours of daylight on the first day of winter. No, I know it's just not enough.
Not enough.
Just leave it. We're all gonna use it.
Yeah, that's why in the mornings in the winter, when you guys come to school, it's still dark. It's just starting to get light out during first and second periods in December and January.
Yeah, but then you can see the sunrise.
Oh, but then you get to see the sunrise.
I love
Silver
the
light.
sun. Love the sun.
None of us get to see the sunrise anymore unless you're out milking cows or something.
It wakes me up because I open my curtains.
Oh, and birds chirping. Aren't these freaking annoying?
There's roosters behind my.
Oh, I love a good rooster.
I ain't seen it.
Anything. Whoa, I've lost control. Back to this.
It's your fault.
It is my fault. I always blame myself. I started. It's definitely, I could definitely, if you guys in a better shape here. I know. So again, you do have to memorize the date. I'll tell you, as long as you remember the month and that it's early 20s, you'll be golden. So you do gotta remember the month. December is the first, is when winter first kicks in. June is when summer first kicks in. Yeah, stay with me, guys. We're gonna talk about the Tropic of Capricorn in the next slide a little bit more. So let's keep going. Let's do the equinoxes. Now they're called equinoxes because they're equal. Instead of having, so we're up here at the top. So instead of having shorter or longer days, they are perfectly equal with the nighttime. 12 hours of daylight, 12 hours of darkness.
Not enough.
My God.
Felicia. I guess you gotta move to the North Pole where they get 24 hours of daylight on the first day of summer.
No, I'm moving for
Okay.
Moving
They get less daylight than us.
Yeah, but still like hotter. It's hotter.
Yeah, because then I can.
Why is it warmer in Florida than us?
Because it's Disney World.
That's not why, Jeff.
Oh.
Even why being closer to the equator does it make them warmer? I want the real science.
They're like hot. The sun.
The sun what?
Like with the because it's at like a 0 degree.
Not 0.
90.
Okay, it's not quite 90, but it is higher in the sky. So you get a higher angle of insulation the closer you get to the equator. Doesn't have to do with this.
I literally knew.
What?
I wanted to look stellar, she went like up to the equator and then back down.
I hope you don't mean up the equator.
Yeah. No, like wrong because the equator goes side to side.
Yeah, so she went from the equator.
Equator is just an imaginary line.
Okay.
I don't even know what movie you're talking about.
We'll talk later.
We'll talk to you, Sarah.
So anyway, again, another reason thing you have to memorize. You have to memorize the March stuff.
That's the day before my birthday.
Okay, good. Sarah's got it. Sarah's got it. And things you can remember because it's the day before Sarah's birthday. The rest of you, if you know Sarah's birthday, you're golden, or you just have to memorize March 21st. It's the first day of spring. Again, if you just remember the month part, the March, and then early 20s, you won't get this wrong. Now, the sun is going to be directly overhead the equator on that day, and 12 hours of daylight, we put in parentheses equal, because I want you to see that equinox, EQU, equator, EQU, and equal, EQU should help you remember what's going on during the equinoxes.
Equal equator.
So sweet.
Pointing directly at the equator.
Yes, that's exactly what it is. And we're gonna, again, that's the next slide. We're gonna focus in on that. Maybe I should have done it first. But we didn't. All right, let's do the last one, the fall equinox. You guys know that fall is also called autumn, right?
Yeah, what if it's like, is it gonna start on the 21st or something too?
What?
I know, I'm sorry, I know a bunch of you can't see this. I can read it off to you if you need me to. It's called autumnal.
What?
The autumnal. Just like spring was called vernal equinox, fall is called the autumnal equinox. So I'm not gonna lie, if you write spring or fall equinox, you're fine. No one's gonna care as long as you know it's an equinox and not a solstice.
Oh, all right.
Also,
So this one is September 23rd. Here's where the date gets weird. So if you just remember the 21st for all of them, I don't think they would mark you wrong if you put down 21st, but hopefully that doesn't pop up as a question. Again, during the equinox, the sun is directly overhead the equator. And again, we get those equal hours of daylight. That's for the whole world.
Good job. I want to go to
Oh, you do you?
Yeah.
They only get 12 hours a daylight. You just said that 15.
That's okay because it's still warm.
That means that if the sun rises at 6 a.m., it sets at 6 p.m.
That's
okay.
fine.
Don't you like those summer nights when it's still light out at like 9?
No, I like.
You don't?
No, I like a dark.
I like when it's always just light out.
No, I'm funny.
I like see again.
Don't you enjoy that?
I don't have a pool, so.
No, night swimming's kind of scary at my house because I'm surrounded by woods and I feel like it's cool there.
Wow. Okay. So let's. Wow. I got no control of it. It's good. Class is almost over. We got 11 minutes left.
Say, girl. Say, girl.
So just to check that we understand the whole equator, Tropic of Cancer, Tropic of Capricorn stuff, we're moving around in the packet, folks. We're actually going back to page 3. I know, all this jumping around. I believe we did the top part of page 3 already, which leads us to, can we label this globe?
Yeah.
Are you capable of labeling the equator, the South Pole, the North Pole, the Tropic of Cancer, Tropic of Capricorn, the axis of rotation, Arctic and Antarctic circles?
Yes.
You need to be able to.
Probably.
I'll give you a hint. Sounds like reference table stuff.
Say, girl.
Page 4. Page 4 has some of these on there. Page 4 was the ocean current map we used before. We also used it for latitude and longitude a little bit, but I don't love it because it doesn't give a lot of latitudes and longitudes. But it is so helpful as to label the equator, which is in the dead smack center. It labels the Tropic of Cancer, which is 23.5 degrees north. It labels the it labels the Arctic Circle at 66.5 degrees north. It labels the Tropic of Capricorn and the Antarctic Circle. What it doesn't label is the North and South Poles and the axis of rotation. But before you start labeling, what's the first weird thing you notice about this picture?
It doesn't look like it's
Yeah, it's tilted, and that's why it doesn't. That's why it looks off a little bit. Okay. So you guys are used to looking at pictures of the globe where it's straight up and down.
That's not how real world is.
Right, but the real world is tilted. So let's.
Why is
Oh my God! Something's going on with this class.
It is a little crazy.
Is it a full moon tonight?
It's not, but I do need you guys to stay with me. So you're having trouble seeing where they're pointing. So I'll tell you that this line is pointing to that spot right there. That is the North Pole. Go ahead and label that North Pole. So then which one's the South Pole? The one at the bottom. Which one's the equator?
The one in the middle.
No, the dotted line is not it. Guys, the equator is
Yeah, that's the one that I labeled.
So then what is the whole dotted line then?
That's like that's the
it's actually not, guys, it's just showing you, yeah, it's showing you that this side is light and this side over here is dark. Wow. So then where is the middle for the equator?
The middle line. I already said that.
No, right there.
That one.
So notice, even though it is tilted, it is still the line in the middle.
Why do we say it's tilted? Why don't we just like look at it now?
Because it is tilted. That's why we say
maybe it's not tilted and the sun's tilted.
That's not it.
No.
So then, how do we do Tropic of Cancer and Tropic of Capricorn? Looking at this reference table. Okay, Tropic of Cancer's north, which you can copy right out of the reference table.
Oh.
So this is the Tropic of Cancer.
So basically it's above
it is 23.5 degrees above the equator, north of the equator. Yep, right there. Yep, good. Use your reference table to just orient yourself. Here's the equator in the middle. The Tropic of Cancer is above that, north, and the Tropic of Capricorn is just south of that.
Yeah.
And then the Arctic Circle versus the Antarctic Circle.
Antarctic is on the bottom.
Antarctic is near the bottom, not the bottom, not the South Pole.
No. I live with two.
I got 100.
Then what the heck is this last label? It's pointing to this line. That's the axis of rotation, guys. What an axis is, just like an axle on a car. What's that?
Axle.
It connects the two wheels.
Roll.
So it would be, if this was your car, it would connect the wheels, and it's what the wheels turn around.
Yeah.
So it's also the axis of rotation.
The axle is like that. It makes it spin.
It is, yeah. So an axis of rotation is the same idea as on the globe. Connects the North Pole to the South Pole, and it's like the pole the world is spinning around. Yeah.
It's like the axle.
Do we have like a line through the earth?
Only on this picture.
Axis.
In real life, there's no line connecting them, but on this picture there is. And I'm guessing on the inside of the globe, there's also a stick. But no, there's nothing. It's making it more fun, but there's nothing.
Well, then the entire world will probably break because of it.
Now, the reason this is important is because during different seasons, different places are getting the direct rays of the sun. Now, we already defined direct rays of the sun on the lines above this. Remember, the direct rays of the sun are locations that are receiving, how did we word it? We said, occurs when the sun is directly overhead. So during different seasons, different places get the sun directly over their head. Before we move on, what season is this for us? What season for us is this picture representing? What season? Spring, winter, fall, summer. Take a look at this, and there's a way to tell. Yep. The North Pole is in the sun. So if the North Pole is in the sun, what season is it for us in the Northern Hemisphere?
Summer.
That's our summer. So what I need you to picture is if you could spin this globe, which I can't, but if I could spin it, then the North Pole would not leave the sunshine. And on the other note, the South Pole is only in the darkness. So for them, it's winter. For us, it's summer. All right, one more page skipping. We're going to go to page, I know this jumping around is not super helpful, but let's go to page 8. Once again, so on page 8, you see 3 different setups for the Earth. Again, there really is only one Earth, one sun, but the Earth ends up in different positions around the sun. And you have to be able to look at these pictures and first be able to tell me the season. So let's look at the top one. What season or seasons is that one, and how can you tell? That's the end of period 5, okay. So now we have until 41, so we have a couple more minutes, not much. What season is this, and how can you tell?
That's spring or fall.
Spring or fall, and that's, I think, where we're going to start is by labeling this the vernal, page 8, or autumnal equinox. And how did you know that was? That's exactly how you knew this one. is that we have the equal daylight and darkness, and it goes down the dead smack center. Because notice down here, there's still equal darkness and equal light, but the kicker is it doesn't line up with the North and South Pole. Here, it's perfectly down the center of the Earth. So, by the way, what date does this happen on? For spring, what's the first day of spring?
March 1st.
First day of fall. And just like Zach said, 12 hours of daylight. But now we got to talk about the direct rays of the sun. So remember, that happens when the sun is directly over your head. So notice how these lines are coming in from the sun and hitting Earth. Which one is hitting? Where is that sunlight line hitting at a 90-degree angle? So see how if I drew a line showing the ground here at the equator, so a nice flat line there. See how this sunlight beam is making a 90-degree angle? Yeah. Whereas up here, if I drew a flat line on the Earth, that is not a 90-degree angle. So where is the direct rays of the sun? This is the equator. And what season could this be? This could be spring or fall. All right, let's just do this for the last two. Who's getting the direct rays of sun in this example? The sun. Okay, which, you need to actually name it though. It is winter, we'll start there. This is the winter solstice for us. Which is what day? And this is our shortest day. So let's talk about who's getting the direct rays of the sun. Is it the equator? Here's the equator. I drew the ground flat. Are they getting 90-degree angles? Who is them? And it needs a name. Tropic of right here. That's Tropic of Capricorn. I keep spelling tropic wrong. And yes, this season would be winter. All right, let's get one more in there. What is this season? Summer. This is summer. And who's June 21st? Longest day. And who's getting that 90-degree angle this time? Tropic of Cancer. No homework.
Did you send my permission slip?
Okay, I'll catch it up.
Yes, sign me up.
Perfect, guys.